That's right.
At least be paying attention.
Good. You are paying attention. You're like, wait a minute. Go to the next one.
I'm like,
We are all together.
man. I'm all messed up. I'm gonna go to the air
All right, so got it. So when we heated this up in our hands, it thought that the superheat was going up, so it opened to let more refrigerant in. So it's going to flood. So our superheat calculations that we did should have.
Now,
What did your superheat do when you put your when you heated this valve up in your hand? The first setting, your superheat went up 7 degrees. Okay, so it thinks that there's a problem, so it's going to adjust. And then when you put this into ice, 32-degree ice water, it should have sensed the opposite. So it's going to react to make a change. And so as it's reacting, then it's thinking that there's a change, and so it's going to open or close, and you're going to see that change on your superheat. So in the field, if you have a TXV, what the purpose of this exercise is to see if that TXV is working. And if you heat it up in your hand, your superheat should change. And then if you put it in the ice water, your superheat should then change the opposite direction. Does that make sense?
So if you're like, just for instance, in the summertime, you're going to fix a unit and it's 115 outside, you go grab a cup of ice because your hand isn't going to change it that much.
Possibly, yep. The temperature this line, though, should still be below your hand temperature.
Yeah.
So if you think that, I think that there's a problem with the TXV, you can at least, maybe it's not set right still, but you can see if it's at least responding.
right.
Heating it up with your hands, your superheat should change, and then you put it into ice water, your superheat should change the opposite direction. Right? Should be. What you need, though, is you're going to have a helper, because this is going to either be in the attic or inside the house, and your gauges, where you take our immediate measurements, are going to be outside. So you're going to have a helper relaying the message. So before it'd be on the radio, talking back and forth, but now you have cell phones. But then wait, let's embrace technology. Outside, I'm going to hook up my digital gauges. It's going to hook up to my little communicator, fits in my pocket, and that's going to Bluetooth to my phone, so I can sit there with my phone, and I can heat this up and cool it down, and I should be able to see the changing effects on it without even having to have a helper.
And one guy, so too.
That's right, but
We need to put into our main
new codes, though. OSHA is defined now, though, that attics are confined spaces. So a confined space means it's more dangerous, right? And people can pass out, and there's been people that died working in attics. They get in the attic, and they get hot, they pass out, and they die. So it is a dangerous working environment. So now OSHA has declared that attics are now confined space. So because it's confined space, you got to write, it's called a permit, but it's really nothing more than writing out a form. You got to go to a training for it, which is an on-class $10, $15, $20 class, and you can be OSHA confined space certified. And all that really means is there's going to be 2 people. One guy's in the attic doing the work, but the other guy has to stay at the entrance monitoring it. So that if you pass out or anything happens, he can tell you. It's not bad because we work with electricity also. So you get electrocuted, right? And so he can call for help. But the idea is that helper that was checking for your gauges is still going to be there at the attic at the entrance. So there still should be 2 people either way.
So if you try to do it quick, like, you couldn't do it like, put a lighter to that.
Well, we don't want to get this too hot. If I get this sensing bulb too hot, then it could damage it. Okay? No.